This is the deepest place on Earth, nearly 11,000 meters down. No sunlight, crushing pressure, and we know almost nothing about it. But now, one country is racing to explore these depths, and not just for science. China is deploying fleets of deep-sea robots, building underwater bases, and quietly moving to claim what lies at the bottom before anyone else can. As the U.S. guts its ocean research programs, China is diving deeper, moving faster, and investing more aggressively than any nation in history. So what exactly is down there? And why is China so determined to get it first? To find out, we spent weeks digging through Chinese research, news reports, tracking vessels, and speaking with experts. What we found points to a much bigger story, and almost nobody is talking about it. Before we can grasp the full scale of what's happening, we need to pull back and understand where we are. This is the Mariana Trench, a massive underwater canyon in the Western Pacific, just east of the Philippines. It is the deepest part of the ocean, and one of the most extreme and hard-to-reach places on Earth. To get to the bottom, you have to travel through the ocean's entire water column. Let's dive down. We start at the surface, the photic zone, also called the epipelagic zone. Here, it's warm and bright, filled with coral reefs, schools of fish, and everything you think of when you picture the ocean. This is the part we swim, surf, and snorkel in. But this familiar layer only goes down about 200 meters. Go deeper, and things change. This here is the twilight zone, or the mesopelagic zone, stretching from 200 to 1,000 meters below the surface. Sunlight slowly fades to near darkness. As you descend, the pressure builds up to 10 times what we feel at sea level, enough to crush most surface-dwelling creatures. This zone is home to bizarre creatures like the oarfish, a silvery, serpent-like giant that can grow longer than a bus. And this here is the sea angel, a transparent, winged slug that flutters through the dark. As sunlight disappears and pressure rises, animals here adapt in strange ways, losing color, growing oversized eyes, or evolving soft, flexible bodies that won't collapse under pressure. The deeper you go, the stranger it gets. At 1,000 meters, you enter the midnight zone. Total darkness. The only light is what the creatures make themselves, a natural glow known as bioluminescence. Animals here look like something from a sci-fi movie, with glowing lures, transparent bodies, and giant mouths. This horrific creature here, for example, is the Magna pinna squid. It has long, spidery arms that can reach over 6 meters and seem to dangle like puppet strings in the dark. Nightmare fuel. Down here, pressure builds to 100 times what we feel at sea level, about 1,500 pounds on every square inch of your body. That's like a full-grown elephant pressing down on your fingertip, and that same force surrounding you from every direction. One of the most well-known creatures from this zone is the blobfish. In its natural habitat at the upper end of the midnight zone, it looks like a normal deep-sea fish, adapted perfectly to the intense pressure. But when it's brought to the surface, all that pressure disappears and the blobfish expands into the gelatinous shape you might have seen online. The blobfish is a perfect reminder of just how extreme the pressure is down here and how life can adapt to survive it. But you keep sinking, and at 4,000 meters, you reach what's called the abyssopelagic zone, or simply the abyss. It's cold, dark, and quiet. Life is sparse, but not absent. And here's where the barren seafloor might surprise you. At first glance, it looks like plain, boring mud. But that mud is deceiving. Have you ever wondered what happens to everything in the ocean when it dies? The fish, the sharks, even the tiniest plankton. Eventually, everything that lives above sinks. Some of it falls as waste, some as tiny particles, digested and expelled by other creatures. Over time, it all builds up. Over millions of years, all this organic matter drifts down and settles onto the sea floor. A gentle snowfall known as marine snow. Layer by layer, it forms soft, carbon-rich mud. In some places, that mud is over 1 kilometer thick, more than 3,000 feet, made from the remains of everything that once lived above. And while these layers preserve the ocean's history, they also trap carbon, turning the deep sea into one of the planet's most powerful natural carbon sinks. But even with all that marine snow piling up, life down here is scarce. Most creatures survive on scraps, adapted to a world where real food is hard to come by. But every so often, something incredible happens. Something massive sinks, and when it does, it changes everything. This here is what scientists call a whale fall.
Whale fall.
Oh, whale fall.
Oh, here we go, baby. Okay,
When a dead whale falls to the sea floor, it becomes a magnet for life. And here you can see it. Deep sea scavengers moving in within hours. First, sharks and hagfish. Then worms, snails, and bacteria. Over time, a whole ecosystem forms around the remains, surviving on a single fallen body. See these tiny hair-like things stuck to the bones? These are worms. One whale can support life here for years, a burst of energy in a place where opportunities are rare. And when it comes, life doesn't waste a moment. And yet, surviving here still isn't easy. The temperature is just above freezing, and the pressure is crushing, more than 400 times what we feel at the surface. That's like balancing 7 full-grown elephants on your fingertip and feeling that weight pressing in from all sides. You're descending further. You're now deeper than 6,000 meters below the surface. This is the Hadal Zone, named after the Greek god Hades, ruler of the underworld. It's trench territory. From here on out, the only places that go deeper are ocean trenches. Very few submarines can even reach this far down. The pressure in these depths is more than 600 times what we feel at the surface. To survive it, a sub needs a near-perfect, pressure-proof design, something only a handful of submersibles on Earth have ever achieved. And finally, at nearly 11,000 meters, we hit the bottom of the Mariana Trench. That's deeper than Mount Everest is tall. And the pressure is so intense that it would feel like 90 full-grown elephants pressing into every fingertip-sized area of your body, from all sides. But here's the incredible part. Life still exists. Some of it in strange forms, like giant, single-celled organisms called xenophytophores that filter food from the sea floor. They thrive under pressure that would crush most life. Tiny, pale shrimp creep silently across the mud. Life here is rare, but it's perfectly adapted to the extreme. So what else could be in these trenches? We know life survives, but there's still so much more we haven't seen. Let's stay at the bottom of the Mariana Trench for a moment. This underwater canyon stretches more than 2,500 kilometers across the Pacific, about the distance from New York to Denver. But not every part of it is the same depth. Because near the western end, there's a point that plunges even deeper. A pit within the trench. If the Mariana Trench is the deepest part of the ocean, then what's the deepest part of the trench? That's where we find Challenger Deep, the most extreme depth on Earth's sea floor. It doesn't go any deeper than this. It was first reached in 1960. A Swiss engineer, Jacques Piccard, and U.S. Navy Lieutenant Don Walsh made the descent in a steel sphere attached to a massive float. That first dive lasted just 20 minutes. Then, over 50 years, no one followed until filmmaker James Cameron dove solo in 2012. He captured footage, gathered samples, and made it back safely. A few years later, explorer and multi-millionaire Victor Vescova built a high-tech sub called the Limiting Factor. He made multiple dives, collecting detailed data from the bottom. But each of these missions had something in common. They were rare, expensive, and mostly one-offs. That is, until China got involved. What comes next might be surprising, because China's deep-sea activity isn't just about science. It opens up a much deeper story, one that doesn't show up in headlines. To tell it properly, our team dug into research papers, satellite data, and government reports. Some of them not always easy to access securely. And that's where Surfshark VPN came in. It encrypts our connection, protects our data, and offers features like Clean Web to block trackers and ads, ensuring a safe and private browsing experience. Surfshark also allows us to access content from different regions, which is extremely useful when researching international topics. It runs seamlessly across all our devices, keeping our work uninterrupted, secure, and without leaving any digital traces. Scan the QR code on screen or click the link in the description to get 4 extra months of Surfshark and a 30-day money-back guarantee. A big thanks to Surfshark for supporting our work. Now, let's look at how China went from one deep-sea dive to something far more ambitious. In 2020, China sent a team of 3 to the bottom in a sub called Fenduze. It was their deepest dive ever. But here's what made their effort different. They didn't stop. They doubled down. Each new sub was smaller, more advanced, and designed to return again and again. By 2024, China had moved beyond crewed missions. And this is what it looked like. A robot no bigger than a shoebox dropped into one of the most hostile environments on Earth. No pilot, no cable. It crawled across the sea floor under its own power and came back intact. That moment marked a shift from rare missions to something repeatable, scalable, and far more ambitious. Because if one tiny robot can do what used to take a massive sub, what happens when you build a fleet of them? By the way, if you're into this kind of deep, untold science, consider subscribing. We go where the headlines don't. Fendazé wasn't the end. It was the start of something bigger. China is developing a new generation of deep-sea robots, small, autonomous machines that glide, crawl, or flex their way through the deep. Built for different tasks, they work together in fleets, covering more ground, more often, and at a fraction of the cost of crude subs. So what are they hoping to find? The deep sea holds more than strange creatures and extreme pressures. This here is a cold seep, a place where methane and hydrogen sulfide seep up from beneath the sea floor. It may not look like much, but these gases feed entire ecosystems. Mussels, clams, and tube worms that survive without sunlight, living off chemical energy instead. Why does this matter to China? Because cold seeps are more than strange deep-sea oases. They're natural test beds. They show how life thrives in extreme conditions. They offer models for future energy systems. And they resemble environments scientists believe exist on some of the moons of Jupiter and Saturn. To a country racing to control the deep and reach beyond Earth, places like this are priceless. Now look at this. What looks like frozen snow packed into the seabed is actually something far more unusual: methane hydrate, or fire ice. It forms when methane gas gets trapped inside a cage of ice under high pressure and cold temperatures. And yes, if you light it, it burns. Scientists are studying it as a potential fuel source, but extracting it is risky. Disturb the sea floor too much, and you could trigger underwater landslides or release large amounts of methane, a powerful greenhouse gas, into the ocean and atmosphere. The fact that we're even seeing this here, at these depths, shows just how far deep-sea exploration has come. And it raises the next question: what other resources might be buried down here? See these round, lumpy rocks scattered across the seabed? You're looking at polymetallic nodules, small potato-sized rocks resting on the ocean floor. Inside, they contain valuable metals like cobalt, nickel, copper, and manganese. These metals are essential for building batteries, electric vehicles, and renewable energy systems. And this is how they're collected. A surface ship lowers a robotic mining vehicle down to the sea floor. That vehicle crawls along the bottom, scooping up the top layer of sediment along with the nodules. Everything it collects is pumped back up through a pipe to the ship. As collector vehicles crawl across the seabed, they kick up massive clouds of sediment known as plumes. These clouds can smother fragile habitats and drift for miles. After the nodules are processed, a second plume of waste is pumped back into the ocean, adding to the chaos. If this ramps up before we understand the long-term impact, the damage could be irreversible. Some scientists warn the sea floor could take centuries to recover, if it recovers at all. And with no clear consensus on how to manage the waste or where to put it, one thing is clear: we're charging into the deep without a full picture of the cost. Many marine biologists are deeply concerned about deep-sea mining as a whole. Those ecosystems are slow to recover and incredibly fragile. Disrupting them could wipe out species we haven't even discovered yet and destroy habitats that took millions of years to form. All of this, the nodules, the seeps, and the tools to reach them, makes one thing clear: the extreme deep sea is no longer out of reach. It's rich in resources, and it's becoming more accessible by the day. But if the deep sea becomes the next resource frontier, who decides how it's used or protected? Right now, regulations are sparse, and ambition is outpacing oversight. China sees that opening. They're not just observing or experimenting. They're getting ready to extract, to claim, to secure what's down here before anyone else does. They're investing in long-term presence. Right now, they're planning to build a permanent base 2,000 meters underwater, designed for 6 scientists to live and work for up to 30 days at a time. It's like a space station, but on the ocean floor. And it gives China something even more valuable than minerals. Time. Time to test new tools. Time to monitor the environment. Time to gain the kind of experience that few others are even attempting. Down here, access is just the beginning. What really matters is what you do with it. China is building the tools, the knowledge, and the experience needed to operate in the deep. Not just once, but continuously. That's how they're pulling ahead, by turning exploration into repetition, and repetition into dominance. The deeper you go, the less room there is for guesswork. And the countries that are investing now in hardware, in research, in people, are setting themselves up to control what lies beneath. And there's one more thing that lies hidden on the seabed, out of sight, yet crucial to the way our world works. It's not rocks and resources, and I'm not talking about the creatures. This is a cross-section of a deep-sea data cable. It might look like plastic and metal, but inside are hair-thin glass fibers that carry most of the world's internet traffic. Messages, emails, even this video, they travel through these fragile lines stretched across the ocean floor. These are thick cables, but they are surprisingly easy to damage. One ship dragging its anchor can knock a cable out. In recent years, Russian ships have been spotted operating near undersea cable routes in the North Sea, raising concerns about sabotage and tampering. So imagine what could happen if someone wanted to cut these cables on purpose. In early 2025, China revealed another deep-sea robot, a literal cable cutter. Officially, it's meant to repair damaged infrastructure. But a device like this could also be used to quietly disable cables, thousands of meters below the surface, out of sight and out of reach, without anyone noticing. There's no proof it's ever been used that way, but the possibility alone is enough to shift how nations think about the deep sea. Beneath the ocean floor runs the nervous system of the modern world. Cables, sensors, and critical infrastructure stretch across the seabed, carrying our internet, global trade, and military communications. They're not science experiments. They're the modern world's lifelines, and they are vulnerable. Control is already shifting underwater. The only question now is, who's getting there fast enough to shape what happens next? Every deep-sea robot starts with a human idea, someone imagining, designing, and building something to survive where people can't. And right now, the country supporting those people the most is China. They're pouring serious resources into ocean science, building new research labs, funding full-scale programs, training the next generation of ocean engineers, biologists, and roboticists. And they're not just investing in their own talent, they're attracting top minds from around the world. Meanwhile, countries like the US are pulling back. Science budgets are getting cut. The current administration has slashed funding for NOAA, the very agency responsible for exploring, protecting, and understanding U.S. ocean territory. While China is flooding its labs with money, talent, and momentum, the U.S. is sidelining the only agency built to compete. Top scientists are walking away, not because they've lost interest, but because the funding is gone. When funding dries up, research stops. But when a country puts real support behind its scientists, discoveries happen. And those discoveries, they shape the future. So what did China actually discover? Not just life at the bottom of the ocean, but a way in, and a reason to stay. They're transforming deep-sea exploration from rare missions into scalable strategy. With compact, autonomous robots and underwater research stations, they're building the infrastructure to operate where few others can. They've uncovered resources that could power the next century. But more importantly, they're developing the tools and experience to control access. They're not just exploring. They're positioning themselves to dictate what happens next. While the U.S. cuts research budgets and pulls back from ocean science leadership, China is surging ahead, faster, deeper, and with a long-term plan. Beneath the waves, a new frontier is taking shape, one that could define the century ahead. And what we choose to explore and how we choose to do it will shape more than just our oceans. It will shape power, security, and global influence. The deep sea is one of Earth's last wild and untouched places. Once it's disturbed, there's no going back. Rushing in without oversight could wipe out entire ecosystems and trigger consequences we don't yet understand. We've been here before. When the race was to the moon, competition gave way to collaboration. The International Space Station proved that nations can work together to push boundaries and protect what matters. We need that mindset again, not just to explore the deep, but to protect it. Because if only one nation controls the last unexplored part of our planet, the cost won't just be scientific. It could be something we all feel. And China isn't stopping with Earth's depths. They're also exploring these massive holes on the moon, strange openings that might lead to vast underground tunnels. What will they find up there? Find out in this video.